All right, all right, all right. Let's take a look. Whoops. Current events. Let's see where we're at. All right. Oh. Hmm. Well, this is fine. Power bank. I'm just gonna leave it alone. Let's go back to exorcism. So where was I yesterday? So yesterday, I skipped over the JQ question, and I'm not gonna return to it now either, to be quite honest. I'm gonna jump all the way over to one that I have not yet looked at. Bank account. Let's go here. This one's closure. All right. Let's copy this. Bank account. Okay. What was space age? Oh, yeah. This one, I messed this one up, and it was like I spent way longer than I should have on this one. What was the thing that I messed up? I don't remember. I think I just did the arithmetic wrong. I don't know. All right, let's look at bank accounts. So what is this one about? Okay, after years of filling out forms and waiting, you finally acquired your banking license. This means you are now officially eligible to open your own bank. Hooray. Okay. Hmm. Okay. So it's a thread safety thing? Hmm. All right. Well, I've never considered up till now thread safety in Clojure, so Clojure, thread safety. Let's take a look. So do sync means this is a transaction. So does it mean it puts some kind of lock on something? Let's see. Oh. Really? The way this is described sounds a little fancy, right? So refs are mutable references to objects. So we have refs here. They can be ref, set, or altered. So they alter it here. Okay. To refer to different objects during transactions, which are delimited by do-sync blocks. So here is our do-sync. All ref modifications within a transaction happen, or none do. Okay. Also, reads of refs within a transaction reflect a snapshot of the reference world at a particular point in time, i.e., each transaction is isolated from other transactions. Okay. Did I understand what I just read? Yes, yes. Okay, so this is good. If a conflict occurs between two transactions trying to modify the same reference, one of them will be retried. All of this occurs without explicit locking. Oh my goodness. Okay. So yeah, we can see that there's not an explicit lock here, but do they mean that there is some implicit lock happening? Sounds like a winner to me. All right, let's start. So if we run the test, what will it say right now? Seven errors. So these are just saying that, hey, you haven't done anything yet, right? Okay. So let's go into our source file and let's take a look. So they've helpfully included convenient stubs for 4 different definitions. Open account, close account, get balance, update balance. Okay. So when we open the account, what do you think we are expecting to have happen? So they called open account, and then they called get balance, right? I guess. Okay. Namespace bank account. I guess the first thing I want to know is when we do this, do we return the account, or is there some kind of like encapsulation happening? I don't know. I don't know if that even makes sense, actually. Um, let's see it in the test again. Huh. Not a lot of accounts, huh? Or excuse me, why did I say that? Not a lot of tests, I mean. Not a ton of tests. Okay. So we did bank account, open account. Then we did bank account, get balance. Huh. And in the README, implement bank accounts. Huh. Okay, so let account, bank account, open account, bank account, close account, account is nil, bank account, get balance, account. Let account, bank account, open account, bank account, get balance, account. Okay, let's, I guess, try something. Let me see one more time. So when they say let account, so we need to give back some manner of like account. So for the arg list, let's see. So closure, arg list. So this is kind of like one of the first things, right? Special forms. Um, so the arg that comes in is an account, right? Oh no, not on this one, on the others. So the account, I feel like, is just a number 0 for the balance, I guess. I mean, I don't know. And then when we get the balance of the account, do we just, if the account is just a 0, do we just give it back? And then update balance, we just go plus. Oh, so update balance, we pass 2 things in, right? It's a deposit or a withdrawal. Should I just say or? And then when we close account, we just give back nil. I don't know. So ran 5 tests containing 8 assertions, 4 failures, 0 errors. Okay, let's just look at the first one for now. Oh, actually, let's not look at parallel access yet. Let's look at this one. Adding money to the account works. Okay, so expected was equal 10, bank account, get balance, account. Okay. Actual, so we got a 0 there. Let's see. So we can do a REPL for closure, right? Let's see how it works. So we do CLJ. Okay, so that opens up. Good. So let's look at the source file again. So that's what I've got. I mean, I don't know yet what we're exactly trying to do. So I'm going to go CLJ. Let's put the test out there. And then let's put the source out there. Okay, so I'm going to copy this definition. Oh, not like that. Guess it should have been cat. Okay, let's try again. I like the syntax highlighting. So let's cat this, cat this. CLJ. Okay, so let's copy this. So now when I do whatever was the first thing here in the test, let's see what this is. So that's not going to work, right? No such namespace. So let's just do it without that. I think we should be okay. So I got a 0 back. So now if I say is, yeah, let's say this. So is equal, and then I'll put a 0, and then open count. Oh. Let's see if it's this. Why did we have an extra? Because it's part of this namespace concept. Okay, so if we just do it without that. Let's see, I think I saw this before. Okay, so class not found, closure test. All right. So let's just put this equals 0, open account. Okay. So now if we do, so then what they did here was like this, right? So let's try. So we put an arrow. What is the arrow in closure? Okay. Sounds good to me then. So we'll put arrow, open account, and then we'll put get balance, right? Okay, so we haven't pasted that in yet. Let's go ahead and do that. Okay, so now we got a 0. And so now we were going to say, oh, is this equal to 0 when we do this? And we found true. So far, so good. All right, so now what about this one? Let account Okay, interesting. So let's try this. So let account, and then in square brackets, oh, no. Which one am I looking at? Increment? Yeah, okay, so let, and then this part is in square brackets. Oh gosh, what did I do? Oh no, I closed right out. All right. Okay, let's cat again. CLJ. Okay, so let's copy this. And these others all at once, I guess. Where'd my music go? Okay. So we're going to try to say let square bracket account, and then we put in parentheses open account. Okay. Okay, so far so good. All right. So now we are going to say oh, I have these backwards, don't I? I need to switch the order of those. All right, let's go ahead and do that. Okay, what's the test say now? Okay, so we still were not able to add money to the account. Okay, so let's cat again. I'm gonna copy these. Okay. So now if I say let account open account and then say get balance account, and then say update balance account 10. And then say get balance account again. Wow, what the heck does this mean? Cannot be cast to class Java Lang number. Oh, word? Did it say that when I ran the test? I don't think so. Okay, okay. Hmm. Okay, so let account open account. That's what we did here, basically, I think. Oh, no, 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 that's not it. Let account open account. Darn you, Lisp! Just kidding, it's fine. Get balance account. Update balance account. Get balance account. So now, you know, it says 0. So, so we're supposed to be updating like something, right? So this part should have given back 10. But we didn't change any kind of state, right? So object state in closure. Let's take a look. I think we're doing something like, okay, what? I think this is going to expand my mind a little bit. Okay. I don't think this has fully told me the answer, but I think we're getting there. I think we're getting there. So we want to use, okay, a ref, right? We already mentioned a ref when I looked at that other page as well, right? So let's figure out how to use a ref. Ref set. Alter. Okay, so the example that it showed here, I think this is going to be quite similar to what we're actually going to do. We ended up using a map here, so okay, whatever. But when we call this open account, we want to create what they're talking about here, right? We want to create an identity. Okay, so let's look at like closure based. Yeah, okay, let's check it out. Okay, so symbols and idents. Is the ident an identity, I guess? Okay, symbol, namespace symbol, null value. Why does it say idents here but not somewhere else? Literal collections. Test your knowledge. I'm scared. I'm scared. Functions. Sequential collections. Hashed collections, nice. Flow control. Namespaces. I've missed the boat on something. Okay, so what we want is not a literal. I think it's that what we want is an ident, right? Okay, let's look it up. Clojure ident. If X is a symbol or keyword. Interesting. So wait, so is that an identifier? Identity is what we want. Okay, so we don't need this. Clearly I didn't understand yet what they're talking about here. I hopefully going to get there. Let's just go through the whole thing this time. Many people come to Clojure from an imperative language and find themselves out of their element when faced with Clojure's approach to doing things, while others are coming from a more functional background and assume that once they leave Clojure's functional subset, they will be faced with the same story regarding state as is found in Java. This essay intends to illuminate Clojure's approach to the problems faced by imperative and functional programs in modeling the world. Okay, cool. Let's go to imperative program. Okay. An imperative program manipulates its world, e.g. memory, directly. It is founded on a now unsustainable single-threaded premise that the world is stopped while you look at or change it. You say, do this, and it happens. Change that, and it changes. Imperative programming languages are oriented around saying, do this, do that, and changing memory locations. This was never a great idea even before multi-threading. Add concurrency and you have a real problem. Because the world is stopped premise is simply no longer true, and restoring that illusion is extremely difficult and error-prone. Darn. Multiple participants, each of which acts as though they were omnipotent, must somehow avoid destroying the presumptions and effects of the others. This requires mutexes and locks to cordon off areas for each participant to manipulate, and a lot of overhead to propagate changes to shared memory, so they are seen by other cores. It doesn't work very well. Okay, harsh. Let's look at this next one, functional programming. Functional programming takes a more mathematical view of the world and sees programs as functions that take certain values and produce others. Oh, lovely. Functional programs eschew the external effects of imperative programs and thus become easier to understand, reason about, and test, since the activity of functions is completely local. To the extent a portion of a program is purely functional, concurrency is a non-issue, as there is simply no change to coordinate. Oh, that sounds nicer. Okay. So now how about this one? Working models and identity. What's this about? While some programs are merely large functions, examples include compilers or theorem provers. Okay, cool. Many others are not. They are more like working models, and as such need to support what I'll refer to in this discussion as identity. Okay. By identity, I mean a stable logical entity associated with a series of different values over time. Oh, wow. Okay, so models need identity for the same reason humans need identity, to represent the world. How could it work if identities like today or America had to represent a single constant value for all time? Note that by identities, I don't mean names. I call my mother mom, but you. So for this discussion, an identity is an entity that has a state, which is its value at a point in time. And the value is something that doesn't change. 42 doesn't change. June 29th, 2008 doesn't change. Points don't move. Dates don't change. No matter what some bad class libraries may cause you to believe, even aggregates are values. The set of my favorite foods doesn't change, i.e. if I prefer different foods in the future, that will be a different set. Okay, good. Identities are mental tools we use to superimpose continuity on a world which is constantly functionally creating new values of itself. All right, cool. So now we come to the GOAT, OOP. All right, so OOP is, among other things, an attempt to provide tools for modeling identity and state in programs, as well as associating behavior with state and hierarchical classification, both ignored here. Honestly, I'm on board. Let's ignore those. Those are crazy. All right, so OOP typically unifies identity and state, i.e., an object identity is a pointer to the memory that contains the value of its state. Okay, cool. So there's no way to obtain the state independent of the identity other than copying it. There is no way to observe a stable state, even to copy it, without blocking others from changing it. Uh-oh, sounds like we just still have the exact same problems we had here, doesn't it? Darn. So is OOP not the GOAT? I don't know, let's see. There is no way to associate the identity state with a different value other than in-place memory mutation. In other words, typical OOP has imperative programming baked into it. OOP doesn't have to be this way, but usually it is. Java, C++, Python, Ruby, etc. All right, so people accustomed to OOP conceive of their programs as mutating the values of objects. Gotcha. They understand the true notion of a value, say 42, as something that would never change, but usually don't extend that notion of value to their object's state. That is a failure of their programming language. These languages use the same constructs for modeling values as they do for identities objects, and default to mutability, causing all but the most disciplined programmers to create many more identities than they should, creating identities out of things that should be values, etc. Oh my goodness, the situation sounds dire. All right, so this brings us to closure programming. Let's take a look. There is another way, and that is to separate identity and state. Once again, indirection saves the day in programming. Aw, this is a nice quote. Hooray. So we need to move away from a notion of state as the content of this memory block to one of the value currently associated with this identity. Oh, really? Oh, really? Yeah, okay, so we need to move away from a notion of state as the content of this memory block to one of the value currently associated with this identity. Okay. Thus, an identity can be in different states at different times, but the state itself doesn't change, right? So we're not mutating, I guess, probably. So that is, an identity is not a state. An identity has a state. Okay, cool. Exactly one state at any point in time, and that state is a true value, i.e. it never changes. If an identity appears to change, it is because it becomes associated with different state values over time. This is the closure model. Cool. So in Clojure's model, value calculation is purely functional. Ooh, that sounds like a win. Values never change. New values are functions of old, not mutations. But logical identity is well supported via atomic references to values, refs and agents. Okay. Changes to references are controlled/coordinated by the system, i.e. cooperation is not optional and not manual. All right, cool. The world moves forward due to the cooperative efforts of its participants, and the programming language/system, Clojure, is in charge of world consistency management. The value of a reference, which is the state of an identity, is always observable without coordination and freely shareable between threads. Amazing. Absolutely amazing. Doesn't this sound like a win? It sounds amazing. So it is worth constructing programs this way, even when there is only one participant or thread. Programs are easier to understand/test when functional value calculation is independent of identity/value association, and it's easy to add other participants when they are inevitably needed. Okay, so that brings us to concurrency. Dealing with concurrency means giving up the illusion of omnipotence. A program must recognize there will be other participants, and the world will keep changing. So a program must understand that if it observes the values of the states of some identities, the best it can get is a snapshot. as they can subsequently acquire new states, but often that is good enough for decision-making or reporting purposes. We humans do quite well with the snapshots provided by our sensory systems. The nice thing is any such state value won't change in hand during the processing as it is immutable. Okay, well then. On the other hand, changing state to a new value requires access to the current value and the identity. Clojure's refs and agents handle this automatically. In the case of refs, any interaction you do must occur within a transaction, else Clojure will throw an exception. All such interaction will see a consistent view of the world as of a point in time, and no changes will proceed unless the states to be changed haven't been changed by other participants in the meantime. Transactions support synchronous change to multiple refs. Okay. Agents, on the other hand, offer asynchronous change to a single reference. Oh, so which one do we want for the bank account? Do we want the ref or do we want the agent? For the bank account, we want the transaction, right? With the ref? I believe so. We'll see. You pass a function and values, and at some point in the future, that function will be passed the current state of the agent, and the return value of the function will become the agent's new state. In all cases, the program will see stable views of the values in the world, as those values can't change, and sharing them among cores is fine. The trick is, values never change means that making new values from old ones must be efficient, and it is in Clojure, due to its persistent data structures. Okay. Let's see. Do I need to go back? So you pass a function and values, and at some point in the future, that function will be passed the current state of the agent, and the return value of the function will become the agent's new state. In all cases, the program will see stable views of the values in the world, as those values can't change, and sharing them among cores is fine. The trick is, values never change means that making new values from old ones must be efficient, and it is in Clojure due to persistent data structures. They allow you to finally follow the oft-proffered advice to favor immutability. Cool. So you set the state of an identity to a new state by reading its current value, calling a pure function on that value to create a new value, and setting that value as the new state. These composite operations are made easy and atomic by the alter, commute, and send functions. Okay, so we're going to be using these. All right, what's this next part? Message passing and actors. There are other ways to model identity and state, one of the most popular of which is the message passing actor model. In an actor model, state is encapsulated in an actor, which is like an identity, right? So, and the actor can only be affected / seen via the passing of messages, or which are values, basically, right? So in an asynchronous system, reading some aspect of an actor's state requires sending a request message, waiting for a response, and the actor sending a response. Hey, makes sense to me, baby. No wonder it's so popular. Ha 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 ha. I mean, it sounds simple, right? So it is important to understand that the actor model was designed to address the problems of distributed programs. Yes, and it does sound like it would address those very well, right? So the problems of distributed programs are much harder. There are multiple worlds, address spaces. Direct observation is not possible. Interaction occurs over possibly unreliable channels, etc. The actor goodness. The actor model supports transparent distribution. If you write all of your code this way, you are not bound to the actual location of the other actors, allowing a system to be spread over multiple processes / machines without changing the code. Isn't that amazing? This sounds like a real winner. Okay, so they say, I chose not to use the actor model for same process state management in Clojure for several reasons, okay? So it is a much more complex programming model requiring 2-message conversations for the simplest data reads, and forcing the use of blocking message receives, which introduce the potential for deadlock. Uh-oh. Yeah, so that is a problem, right? Darn, it seemed so good until you had to splash cold water on the reality of the situation. No! Okay, so programming for the failure modes of distribution means utilizing timeouts, etc. It causes a bifurcation of the program protocols, some of which are represented by functions and others by the values of messages. Okay. It doesn't let you fully leverage the efficiencies of being in the same process. It is quite possible to efficiently directly share a large immutable data structure between threads, but the actor model forces intervening conversations and potentially copying. Reads and writes get serialized and block each other, etc. It reduces your flexibility in modeling. This is a world in which everyone sits in a windowless room and communicates only by mail. Programs are decomposed as piles of blocking switch statements. Okay. You can only handle messages you anticipated receiving. Ah, true, true. Coordinating activities involving multiple actors is very difficult. You can't observe anything without its cooperation/coordination, making ad hoc reporting or analysis impossible. Instead, forcing every actor to participate in each protocol. Sounds a little harsh. Sounds like we're being a bit harsh on the actor model here. It is often the case that taking something that works well locally and transparently distributing it doesn't work out. The conversation granularity is too chatty, or the message payloads are too large, or the failure modes change the optimal work partition. Sorry. Let me start again. The failure modes change the optimal work partitioning, i.e. transparent distribution isn't transparent and the code has to change anyway. No! Alright, so Clojure may eventually support the actor model for distributed programming, paying the price only when distribution is required, but I think it is quite cumbersome for same process programming. Your mileage may vary, of course. Okay, cool. Let's take a look at our summary. So, Clojure is a functional language that explicitly supports programs as models and provides robust and easy-to-use facilities for managing identity and state in a single process in the face of concurrency. In coming to Clojure from an OOP language, you can use one of its persistent collections, so like maps, right, instead of objects. Use values as much as possible, and for those cases where your objects are truly modeling identities, far fewer cases than you might realize until you start thinking about it this way. This is a good point, right? Because a lot of times, if you're using like an OOP language like Java, you might end up having objects for all sorts of crazy things. But anyway, so truly modeling identities, far fewer cases than you might realize. Yeah, totally. So then you can use a ref or agent with, e.g., a map as its state in order to model an identity with changing state. So if you want to encapsulate or abstract away the details of your values, which is a good idea if they are non-trivial, write a set of functions for viewing and manipulating. If you want polymorphism, use Clojure's multi-methods. Okay, I don't know anything about the multi-methods, so I don't know if I'm going to find out anything about them today, but in the local case, since Clojure does not have mutable local variables, instead of building up values in a mutating loop, you can instead do it functionally with recur or reduce. Okay, so this is part of the Clojure about. So clearly I think what we want is we want to have a ref to a bank account, and then we want to be able to alter that bank account, right? So where's Clojure ref? Clojure ref. Okay, so the ref is pretty important, right? Creates and returns a ref with an initial value of x and 0, or more options in any order. So how are we going to... Oh, hold on. This actually does seem like it's going to be pretty simple, maybe. So let's close here and go back into our code. So instead of returning a 0, we will return a ref with a 0 value. Okay. If we close a count, we will return a nil, I guess. I think we probably need to do more than that. Okay, so now here, but I'm going to come back to that one. I want to do get balance first. So when we get the balance, we want to get the value, of course, off of the ref, right? So here are some examples given. Somebody has a ref. And they're using a ref set. I think we probably are going to want that. But so create. Okay, so dref. Do we have a link to dref? We have dref in examples, and I really appreciate that. Okay, so if we put dref into here, do we go straight to it? Amazing, amazing. This is a great site. Okay. Cool. So I think that means that all we have to do then is put dref account. All right? Okay. So now we are going to need to use the transaction, which is do sync, right? Where did it say that? Oh, okay, yeah. The transaction is delimited by a do sync block. Okay, so when we update the balance, we are going to need to do sync to have a transaction. And it looks like the do sync where do we think this it's so many. Let me copy this and oh no. Let me copy this and put it into my editor. Okay, so this is what I got out of there. All right, so okay, so I've got some extras there that definitely do not make sense. Okay, so that's where I want it, I think. Okay, so do sync, do sequence. I don't think I need that. Let's look at alter. I want to say, oh, that's alt. Where's alter? Okay, so must be called in a transaction, sets the in-transaction value of ref2. Apply fun. Okay. Oh my goodness. So they put that in, which was the ref. Okay, so the ref, so we won't have that and we won't have that. Let me move this back over. Whoa, these tab sizes are really tiny. Okay, so this one will be account. Plus will be it. This value will be deposit or withdrawal. And then in this example, they had a T here. Wait, what is the and here? There's only one example given. Alter. Yeah, I think we're good. I'm not sure what the T was supposed to be there. Well, actually, let's go back to the example. So they had a T here, which was from the map. All right, I don't think I need to worry about that. So let's just get rid of that. All right. This one I think is going to need to be different, but let me try what we've got so far. Actually, I'm really liking this. Like, let's look at a review of what's in there. Like, if this is actually how it's done, then this is so smart. Right? If it's really as advertised in that whole long essay I just read. Like, holy crap. This seems really smart. Let's see what the test says now. There's no way it's like as simple as this. Okay, so it says fail. Okay, so closing an account makes it nil. All right, and so we did not get it to be nil. But interestingly enough, okay, so alter was one option, but we also have commute and send. So what are commute and send? Where'd send go? Okay, so send, dispatch an action to an agent. Oh. What about commute? Do we have like a... Okay, I like this site, clojuredocs.org. This seems like an amazing site. But do we have like... Okay, we have C also. We have ref. Oh, I think we need ref set. Must be called in a transaction. Sets the value. Let's try ref set and try setting it to nil. I'm not sure if that's what we want. But sure. So get balance. Oh, do we need a transaction block for getting the balance? I don't think so, right? Yeah. For thread safety purposes, we only need it. We only should need a transaction block if we're changing something, right? And we are for sure changing something here, so we need a transaction block. Do sync. Okay. And then in here, it's gonna say set ref account nil. Yeah, seems like it. Let's see what it will say. Oh, it didn't compile. Unable to resolve. Oh, it's ref set. That was a brain fart. Ref set. Okay, how's that? So ran 5 tests. So there weren't any tests disabled, were there? There were only the 5 tests in there, right? Let me just take one quick look. And I'm gonna move on. I'm not gonna try to second guess or refactor this right now. I think it's super, super interesting. Like, I do want to just at least review it. Like, is this like really how we do thread safety in Clojure? Because if so, this is so simple and elegant, and I love it. I love it. I love it. But I don't know. I'll have to learn more at some other time because I'm just gonna move on. Okay. It says it's a medium, which makes me wonder if I actually messed something up here. But I think it's okay. Because, sir, I don't think this was a medium. I do think this was an easy. So if it's ranked as a medium here, I wonder if I might have screwed something up that wasn't caught by the tests, because that can happen sometimes. But in any case, I'm going to move on. Let's do another one. Okay, let's close out all of these tabs. So many Clojure tabs, baby, and yeah. I do feel like reading that whole essay was the right move, because I think it made a lot more sense after having read it. All right, so what's next? So bank account in Erlang. Oh, man. And then in Java, oh, man. I think I need a brief break, actually. For some reason, the thought of jumping right into Erlang right now, I gotta do it at some point. I mean, which one did I do in Erlang already? There was one, wasn't there? Maybe not. I know I've opened Erlang, but I might have tried one and not completed it. Oh no. It says I've completed 2. What were they? All your base? Is that here somewhere? Did I just miss it? Where's all your base? Oh yeah, there it is, Erlang. Okay, so I did complete 1. Let's see what my code was like for this one. Okay, so I included quite a bit of commentary here because I was pretty confused. I do like this syntax a lot. At least I think I do. I don't like every... Oh, I think I do like it a lot, yeah. All right. I'm gonna step outside for a little bit, for like 5 minutes, and come back. And then... At the moment, I'm leaning towards just skipping over these and going to Lua, but I'll make my decision when I get back. All right, BRB, give me 5 minutes. All right, let's look at the Lua. All right, what are we doing? Interesting. Okay. All right, so we've got some different tasks, I guess. Let's see. I'm gonna look at the spec first. All right, let's see what's in our file. Think they gave us any stubs? Just a little bit of one. All right. I'm gonna copy the spec into here, actually. So how come here they're using the colon? Is that because it's like a namespace type thing? Hmm. Was there a colon in here somewhere? Oh yeah, what's this? The method call has a colon. Okay, gotcha. So we're gonna have function school new, and we'll put this here. Okay, and function. Wait a minute. So they called new with a big S like it was either like a constructor or a static or something. So static method in Lua, something about this. Hold on. So they created the account like this. Oh, hold on. So the school is just a table with nothing in it. The new is going to need to return a different table that is going to need to have functions on it. Okay. So I'm going to say school equals this. I don't know if I need local or anything like that, but let's just say, let's say local to start with, maybe. So in the end, we are going to return school. Okay, so what do we do before that? We add functions, right? I think. So function school roster. I'm going to put end there. Okay, then the next one is going to be function school add. And this takes a name and grade. Seem okay so far? I think so, yeah. Okay, so that covers roster. And then add. Okay, so we've got add, we've got roster. So then what's grade? Returns the students in that grade. Okay, so grade is the last one then. Okay, easy. Okay, so for roster, we are going to return all of the students. Let's put add in here first. So when we add, we are going to say self, right? And then we are going to put something in the list of students that we have, basically. So when we do this, we'll say students equals this. Is that how we do a list? I don't think it is. Lua list. Lua list. I think I did them. Oh, it's an array. And how do we... Oh, okay, okay. Okay. And then append is going to be... So this is arrays. And then what's the next page here? Okay. All right, that's fine. Okay, so if I don't necessarily have a way to append, maybe there is, but I'm just going to put size probably. So it grows as we need. Sure. So, and it's one indexed, we have to remember for sure. So I'm just going to put size equals 0. So then here I'm going to say self.student sub self.size plus 1. No, I think let's increment the size first. So self.size equals self size plus 1. So then we're going to add a student, which has name equals name and grade equals grade. Will that be okay? We'll see. And then, I mean, I guess that's it, right? So we added it. But then the trouble is we're going to need to filter that when we get grades. So if we can filter it, then that'll be fine. So let's see here. Array filter Lua. Do we have that option? It looks like somebody has a gist. So perhaps we don't want that. So let's instead try maybe a multi-dimension array, since I did see that mentioned. Where was that mentioned? Right here, right? So in that case, we would not really have a size. So it wouldn't be like this. Instead, it's going to be self. Let's see. Why is this student? Let's make this grades. Self dot grades subgrade. So should we check if that exists? Can we check like if that exists? Probably, right? Oh, where's the Lua REPL? I want to be doing a lot of this at the REPL if possible. I think it was just, I think you could just do Lua, right? Yeah, okay. Okay, let's stop messing around and let's just do it in the REPL. So let's look at this. Oh, yeah, I copied that whole thing into there. Okay, so let's just do Lua. So let's say that we do this. Okay, so school grades. Should we do this? Okay, so there was some table there, I guess. Sure. So we can check if it equals nil, right? So let's do that. So we're going to say if self grades grade equals nil. Let's just quickly review if statement Lua. So do we do like if then? Okay. If self, so then we'll say then self grades grade equals this. Okay. The else part is optional, but we do need an end. So let's put end. And then what about this? So then we'll say Oh, but we need a size in there, don't we? Size equals 0. Student equals this. So we can put them in there. So then we'll say self grades grade size equals self grades grade size plus 1. Why are we doing that? Don't we have increment? Lua? Ah, there's no shorthand? Okay, well, fine. We'll just do it that way then. Okay, so that should be fine. And then we'll say self grades grade students sub self grades grade size equals name. Right? And that's it, right? Okay, but there's a problem because we're supposed to disallow. I feel like I have very much made this more complicated than it ever should have been. So we're supposed to disallow duplicate names, right? And that's not going to work like this at all. This is going to completely allow duplicate names. So can we have a hash set or tree set in Lua? It's not anything like that. Is there something like that included there? Very well. Oh, yeah, it looks like it. Sets and bags. Amazing. Amazing. Okay. That is fair. So let's look at add. Oh, wait a minute. Does it even test for whether it's going to reject duplicate names? Looks like it doesn't, but it told us to reject duplicate names, so let's just try to do that. And you know what? Let's even add our own test for it if it doesn't exist. So we'll say if self dot names. Oh, so we already looked. So if the if whatever name it is does not exist in there, then it should just come back nil, we think, right? Subname not equal, and in Lua it is squiggle for not equal, right? Nil. Then, okay, but can we like throw an exception? Oh, that's a good question too. I have no idea. Error handling, yeah, hit me with it. Okay, okay. So should we just say error? Okay, let's give it a shot. So now we'll say self names name equals true. Okay. I think that should be it for add. I feel like I'm moving real slow on this one. Maybe not that slow, but whatever. All right, so for roster, we're supposed to return everybody. And when we return the roster, it's supposed to be in... Wait a minute. So, okay. If the students' names in each grade in the roster are sorted. So we're supposed to return... each grade in turn. All right, we'll see how it goes. Let's see if I'm gonna guess we have a sort available. Lua sort. Does this sort it in place? What does it do? Okay, so table sort. Let's just try it. Well, you know what? Let's just put it in there. And then, I don't know, whatever. No, wait. So I guess, shoot, I don't know. So we said table sort. It looks like it should sort it in place. Does it say that? It doesn't say in place. I think we're okay. So I think we maybe just have to do table sort and pass in, what was F? Optional parameter F? Yeah, I think we just have to table sort it, I guess. So table sort self grades grade students. Interesting. Yeah, something about this seems really weird. Okay. I think something feels a little off to me, but okay. So for this one, we, I guess, just return the school. No, we don't return the names. We return the grades. Return self grades. I'll try it. I think some of this is quite wrong, but we'll see. Okay, so then here we return self grades grade. Okay, let's see what the test says. It looks like none of them worked. I don't know, maybe some did. Let's see. All right, all the way up to the top. Okay, so something worked, I guess. Which one worked? Do we know? Does it matter? Running tests via busted. Okay. All right, so passed in something or other and expected something or other. All right, so okay, so expected was supposed to be 2. Oh, okay. Okay, that makes sense, I think. Yeah. Okay. So I think what I'm gonna do then is something. So I have the information that's wanted, right? So I have a size and a student, but it was really just supposed to point to this. And so something that I saw in here seemed like it was useful, right? So for n in pairs, lines, do table insert a. Huh, interesting. So, when we add, I feel like I want to like create this view. At this point, something has me feeling weird about all this. Okay, so we'll sort. Okay, so far so good. And then I'm gonna add a view, which is gonna be another array. And then I'm gonna say self view grade equals self grades students. And so then here we'll return view. Okay, so 5 passed now. All right, so this one, we got this back for the grade. Okay, so we'll use the view here as well. Okay, and for this last one, okay, so return an empty array if there are no students in that grade. Okay. So we'll say if self view grade equals nil, then return empty, else and then just do this. All right, I'm gonna submit that. Something about it felt like just sort of annoying to work with, to be honest. Maybe I'm not a fan of Lua. Maybe Lua has not won me over yet. Let's try whatever's next on it. So we'll close all these. I don't think it was legit annoying to work with. No, it annoyed me, but like I don't think there was anything objectively wrong with it. I think it just hasn't won me over yet. Let's see what the next exercise is. Gleam? Yes, I think I do want to do this one next. This could be interesting. All right, let's go to the Gleam. So let's see what our file looks like this time. Oh, nice. We have more stubs in here, so that's cool. So we have a create, which is supposed to return a school. It just says to do here because we don't know what goes in there yet. You know, I think I had a pretty good time with Gleam before. Hey, look, I'm getting some pretty nice hints here too, but the syntax highlighting does not look right. I want to look at that first. Vim Gleam. Syntax highlighting. Okay, if I could even spell a word. Oh boy. Alright. If I do this, I don't think it's going to work because I don't think I have a tree sitter installed. Let's take a look. TS install Gleam, not an editor command. Tree sitter Vim. Heated discussion. Oh, goodness gracious. Okay, not going to worry about that. Is there anything else I should look for? Should I do a plug install? Let's see. I might have a... I don't know what plug I might have in there already. So there's no Gleam in here. So sure, let's add this. Whoops. Yeah. Okay. Okay. Doesn't look any better. Oh, and yeah, that does look better. Okay, cool. Great. I love it. So, all right. So we have a type, which is a school. So what are we imagining that this school is going to need to be? Is it like some kind of struct or something? Let's see how types work in Gleam. Gleam type definitions. Okay, so they did a type that was a season, spring, summer, autumn, winter, sure. Seems fine, I guess. So, but whatever we do, we're going to want to be able to at least store some data in this school. So it's something like a struct or something, right? Gleam struct. School person. So a variant of a custom type can hold other data within it. In this case, the variant is called a record. Okay, so this is a record school person. So we're going to want a record as well, right? Okay. This doesn't... No. No, I still don't quite know. Let's see what's next. Record accessors. Okay. All right. So in this case, is it gonna be like simpler than it was in Lua? I don't really think so. So we think this school is going to have something in it. So can I say this is going to be a school and it has a list of lists of strings, I guess? Does that seem right? Not really. We need a map. Lists. Tuples. Records. Okay, so the school will have grades, I guess, which are going to be a list. Okay, so hold on. Where'd records go again? It's going to be a list of int list string tuple. Okay, so it's a list of these tuples. So the int is going to be the grade number, I think, and this is going to be the names of the students. But we again, oh, and in the Lua version, I didn't even check about the thing where you're not supposed to allow duplicate names. Let's see if the README still says the same thing. I think it will. Okay. So school grades. So then I guess we should have names. I don't like it because like it's redundant. So really, really what I'd rather do is have students, each of which has an int, which is a list of students, each of which is a tuple of an int, which is their grade number, and a string, which is their name. Hmm. Do I need an extra set of parentheses, maybe? No. Key filter. Given a list of two element tuples. Oh, is the hash used for the tuple? Did it show that already? I completely overlooked it. Okay, so we want a hash here. That's a tuple. Okay, okay. So then these other functions I want to have like just transform the list of students into the list that's wanted. I like that idea better for myself, I think. The way it was done in Lua, it bothered me. I think I'll like this better. Let's see if I actually finish it. I've got plenty of time left for tonight. It's still pretty early. All right, so when we do this, we are just going to return like a school, and when we look again at what it said for the records, I have looked at it like 5 times already. Okay, so we just say school, and the list should have nothing in it, right? So students will be list like this. What am I doing? It's this, right? I know it's this. Okay. Oh man, I think I'm all over the place. Give me a minute. Give me a minute. What am I doing? What am I doing? All right. That should be fine. So this one is going to be much simpler than it was in Lua because we're just going to add the student to our list. So we'll say to school. Oh, they use 2 different names like in Swift, I guess. left off the hash. We don't need this. There. Yeah. I like it better the way it's done in Erlang, but I guess this is fine. Okay, so this is where we have to check whether the name is already in there, right? I feel like checking for membership in a set should usually be constant time, but this time I guess we'll just go through and check for it. So, gleam list, yeah, right there. Okay, so list, continue all, any. Okay, so we'll use any. And let me see the if again. So we'll say case, and then we'll say list any. And then we'll say in, and that's going to be school students. And then the satisfying, spell that right, okay. Satisfying, and then we can just put a function like this. Okay, so function student equal, or let's see here. And then what was the tuple again? I keep looking at every little thing like 5 times. So .1 should put out this number here. So .1 equals, function s s.1 equals student. Yeah? So that would be the case. And so true will be error. And then in the error, what did it show us doing with the error? So they said not enough money. But it says nil here, so I don't think we have to do anything. What are Boolean literals? And then this one will be okay. Like this, right? Okay. Give me the hint. It says no module has been found with the name list. Is that how you do it? No. So we do gleam list any. So do we just do any? Do we not have to put the thing on the front? Gleam. So what did it call it? It's a module, or what is it? List. Gleam slash list. Gleam import module, or whatever it is. Let's take a look. Okay, so we want to import gleam slash list, right? Okay, so this is going to be list any, and we're going to say at the top, import gleam list. Yeah. So is that okay now? Okay, now what's this one? Okay, so something is supposed to go in here. I think it's nil, right? Okay, so far so good. Hey, you know what? It's shaping up. It's shaping up. Okay, so now what do we think we're supposed to do for the grade? So this is going to be sort. Let's see if sort is in here. We have shuffle. We have sort somewhere. Okay, sort from smallest to largest based upon the ordering specified by a given function. Okay, so we're gonna, for grade, we are going to return sort. I think we have to put list sort. And we will put in the list that we started with, which is going to be school. Okay, so then we filter, right? Okay, so we're going to say list filter, and we are going to be list school students. All right. And then keeping will be fn s, I guess. And then we'll say s.0 equals desired grade. Okay. So then let's go back to the sort. And it says, we'll put list. Okay, so then this one will be by. Okay, let me just do that. And then the by will go down here. So this will be function s. So then now we need a string sort. So let's look at gleam string. Oh, interesting. Oh, compare. Perfect. That should work. Okay. So we will import gleam string. And this will be by string compare. Okay, so now it says, let's see. Oh yes, we have to map. Okay, so let's take a look at the map. Interesting. I think I just want this map, right? Yeah, that should do it. Okay, so it's going to be list map, and we do list like this, and then we do width, and then the function s will be s. Okay, so now it says unknown label. For list map, it looks like it should be list and width. Is that better? Okay, so yeah, I guess I don't know whether we should have the labels or not. Looks like probably not for the most part. Okay, so that sort won't work. So we want to sort after mapping, right? So this goes in here, I think. Okay, so we sort. We pass in there the map, which takes this. I think that seems right. Okay, last one is roster. So here, I'm actually just, I want to run the tests. So for now, I am just going to put school students, which is not what we want. Oh, let's do, oh, you know, we should be able to do a piping, right? School students into list map function s. That's you can do it like that in Elixir. Okay, good. I think it does allow that. Okay, so that's not going to be correct, but let me just see the test result real quick. And then I want a Gleam source code formatting command. Something like that. Add, build, check, clean. If they have format as part of this, oh my gosh. Yes. Amazing. What an idea. Okay, so we did fail 4. I think that it's just the roster thing. So when we return the roster thing, wait a minute. Oh, you know, it looks like they're sorted. They should be sorted in reverse order, I guess, maybe? No. In the roster test. Okay, so they're not sorted in the roster right now. Gleam. Oh, how do we add the Gleam ZSH completions? I'm still very much not used to a lot of this tech for Gleam. I don't see anything, so I'm not going to worry about it. So Gleam help, Gleam format. Did it format it? Let's take a look. I don't think so. It looks the same, right? Gleam format help. Is that formatted? Oh yeah, I think they added a comma there. All right, it's whatever. So to finish up, I think we need to totally sort this. So let's pipe again and say list sort, and we'll pass string compare. Yeah, let's see what it says now. Okay, so a couple passed now that had failed before. So sorted by grades and then by name in the roster test. Ooh, interesting. Okay, so we want to sort by string compare, but then no. Okay, so I think we want to sort twice. So sort so function s. So wait, what gets passed in? Is it like an S1 and S2 or something? Where's the sort? Function AA. Okay. So S1, S2. So it's going to be string compare S1 dot 1 S2 dot 1 Okay, and then sort again, I think. And so let's drop each of these down onto a new line right here. Okay, so then here it's going to be sort function s1, s2, int compare, and we may have to probably import that. S1 0, S2 0. Okay, so that's straightforward now that I see like what I think it's supposed to look like. Okay, so no. Okay, sorted by grades, then by name. Let's see. And then it said they're supposed to be smallest to largest. I think that is what it's supposed to be. So do you think they're out of order? I don't think so. Sorted by grades in the roster test. Okay, so that's not it. It's so sorted by grades and then by name in the roster test. Okay, so I think it should be just, wait, so what does the compare function return? An order? Oh. Order.eq, order.less than. Okay, so this is gonna have to be a little bit more than that. So it's gonna be case string compare. Wait. So it's grade compare first. So int compare s1.0 s2.0. Okay. And then it'll be order. So do we have to import that? Import gleam order. Okay, I think so. So then order dot lt. We say order lt. Order gt. Order gt. But then the order EQ is the interesting one, right? Where now we have to do string compare S1, S2. Okay, so this is our sort function, S1 and S2. We're going to try to do a case by doing int compare. Nope. Still no good. Sorted by grades and then by name. So Alec, let me look at the spec. So Jim is 3. Okay, so it should be ascending order of grades. Makes sense. Yeah, I want at least this one to pass first. Sorted by grades in the roster test. Okay, so... Huh. So... No, why... How am I screwing this up? Oh no, I have an extra sort there. Oh my goodness gracious. Oh my goodness. Okay, let's move on. I still have a good amount of time for tonight. I was not looking on the right line. It was so close to where I was looking, but I wasn't looking at it. That's crazy. Okay, let's see what it says. Okay, I'm going to close out this Gleam information. I'm just going to move on. Okay, let's close all of these out and go to grade school in whatever the next language was. I think it was like Bash. What was it? It might have been Windows CMD, actually. Oh, it's PowerShell. Oh, PowerShell. I did a PowerShell already. All right, this shouldn't be bad, I don't think. We'll see. We'll see how it goes. No, not Hello World. We want grade school. Okay, so if we try running the test, what does it say? Executable file not found in path. This is something I should have fixed previously. But I didn't. So this is supposed to be added to the path in our ZSHRC. Invoke pester. Okay, let's Google this and see where it thinks the path is supposed to be. I did run them before, I just neglected to add it to the ZSH file. I neglected to add the path to the ZSH file. That doesn't seem right. Okay, okay, what is this? Oh gosh. PWSH. Oh, that did work. Okay, cool. Okay, I don't know how this is gonna go, but I do think I'll finish it. I've got plenty of time, and I mean, it's not very complicated, right? I've already done it twice. Oh no, what is all this? Oh my goodness gracious. Synopsis. Okay. This is a PowerShell file? Alright. Synopsis. Given students' names along with the grade that they are in. Wow, somebody went all out creating this stub. This is crazy. Okay, so in PowerShell we can create a class. That's oopish. And a roster as well, apparently. My goodness. So we have a student class and a roster class. Okay. Please implement this class. Okay. PowerShell class. Let's see. About classes. Let's take a look. So the definition, interesting, interesting. That's fine. Do we have an example? Okay, minimal definition. Class device, string, dollar brand. Interesting, interesting. Okay, so do we want to try and do it like similar to how it was in Gleam? So the student we think is going to have, okay, so class book. I'm in the constructor right now, right? Book. Here's a default constructor. Okay, so let's not go in the constructor yet. Let's just go into the idea that it has a string, dollar name. Is that how we want to do it? I guess they're using a capital letter for the most part. And a int dollar grade, right? And then in the constructor, well, I don't think we're going to have a no-args constructor. I think when we do the constructor, we need to pass those in, right? So it'll be string name int grade. Yay! Okay. So then they're using this sort of $this dot init. Is this the way to do it? This seems convenient. Convenience constructor for hash table. I don't think we need to do that here though. So they do at is okay, so is this at symbol for a hash table? Everything you wanted to know. Oh wow. So this is PowerShell. So they do an at for an array with a round brace, and then they do an at for a hash table with a curly brace. Okay, so that is fine. So we are going to go $this init and pass in those things, right? So title and author. All right, so we'll say name equals $name. Okay. Grade equals the grade. Yeah. I guess. Wait a minute. What the heck am I pressing? Oh, do I have caps lock? Oh, nice. Okay, so that was it. So that's our constructor. That's all we need for the student, because it's not doing anything with that. But the roster has several methods, right? So this one does have a no-args constructor. So it also should have, just like in Gleam, let's do a student array. Students. Okay, so then we'll say this dot init, but without anything. Okay, sure. Okay, so then we need a method. So Add student, I guess, is going to be a void. So they put void here, so sure. So that will be add student. They don't do a dollar or anything, do they? Student. And then that will take 2 args in it. Okay. So then we will have a int dollar grade and a string dollar name. Okay. And then in here, we will say dollar this, dollar students. Is that how we, so in this example, when we want to reference some of these, this dot page count. So there's not a dollar there. So let's get this dot students. And then we're going to add append. I think so. Okay, so then do they call new like this? Is that the idea? Like when we instantiate the book, we go book colon new and we put all that in there. All right. So we'll go student colon new, and we will pass in, I guess I kind of reversed the order. I'm okay with it. Name and grade. Yes, so we'll try to add that. And that's the end of this. Okay. Let's add another one. So then we'll have get roster. So that will return a student array. It's called get roster. Okay, so I guess we have this one overloaded. So we have one that takes nothing. So let's do that one first. So I'm gonna say, do we have to say return when we do this? Yeah. Okay, so we'll return this dot students. But we're gonna have to like sort that or something. So it's not correct yet, but let me just do the overload here. So get roster. So in this case, it takes an int grade. Okay, cool. And so here, we're going to return this student's. So now we want to filter. So PowerShell is a .NET thing. In .NET, they have link. And in link, I think it's like where. Because it's like they use terms that are similar to SQL, right? So PowerShell link where. Oh. So according to this, it sounds like it's not what I was hoping for, right? Oh, never mind. Okay, so I guess we'll try to use link. Okay, let's give it a shot. So we'll go system link. Is it all caps? enumerable, okay, where, okay, so then we'll put in this dot students, okay, and now we should put in the lambda, right? So they went func. Wait a minute. So this one put func here. This one tried to put it in without anything. Okay, so we will try putting a func, which takes, what do we want to pass in to the func? It'll take a student, right? Student and return a bool. Is that how it is? Yeah, I want to say that's probably how it is. So it's a predicate because it returns a bool, right? And now it will be, so we'll put a param. Okay, so I'll put $S for student. Yeah, I guess so. And now we'll put $S dot grade equals grade. Okay, I mean, I think that's what it is. Huh. Okay, so we've got the two get rosters, we've got the add student, and we've got the constructor. Let's try running the test. Oh. So they all failed. Does not contain a method named init. Interesting. So in the example I was looking at, they had a default convenience constructor from hash table. Wait a minute. Yeah, I misspelled it. It has to be init with a big I. It's always a big I in .NET world. Or like all method names are capitalized is what I mean to say. Is that any better? No. Okay. Oh, does not contain a method named init. So this .init. Okay, so shared initializer method. Huh. Well, you know, actually, yeah, okay. It led me astray because I didn't read down just like 3 lines further down. Okay, let's do it again. So we don't want init, that's crazy. We just want to say this name equals name. This grade equals grade. You know, I mean, honestly, and the way they were doing it was a nice, obviously good practice or whatever. So in this case, the constructor has to do what? It has to say this student equals student new. That, I don't know if that makes any sense. Let's see what it says. I'm not sure we need to do anything. Well, hold on. So here they have tags. Oh, at. Oh, yes. Okay, so I did see that before. So we'll say, this student equals at. I keep doing that. Oh, something passed. Let's see. So, I mean, I guess it's good if something passed. Does it show what did pass? So exception calling add with one argument, collection was of a fixed size. They all say collection was of a fixed size. Okay, so we don't want at this, we want an actual list. So PowerShell list. In .NET, they call it a list, right? Okay. So an array is fixed in size. So we do plus. Okay, so let's see what array addition. Okay. That seems fine. So it will be this student's plus equals student new four passed now. Okay. So I think I'm going to get this finished before too much longer. It's still pretty early in the evening, too. All right, so expected true, but got null. Oh, interesting. So I guess it wasn't void after all. So we have to check if it's in there. So link .NET link. Let's see. Do we have just an overview? Yeah, exactly what I want, an overview. So we can do where. Can we do any or some? This isn't quite it. I think I just want to see a brief list of the different methods. That seems fine. Overview. Okay, so filter, sort, partition, group. Um, I'm not sure I'm in the right place. Yeah, it's been a while since I've looked at the Microsoft docs much. They're really like comprehensive, and that's great. But I do recall that it took me a while to get accustomed to them, and I'm way out of practice looking at the Microsoft docs. All right, so quantifier. Ah, perfect. I didn't know if it was quantifier. Okay, so any. Okay, so let's try it. So I'm gonna say, oh, and let me take a look at PowerShell if statement. I think it's very easy. Everything you wanted to know about, I like the way they call it that. Okay, so we're going to say if, and then we're going to put system link enumerable any this student's func student bool curly param $s for student $s dot name equals name. Okay, and then okay, so what's this say? Are we any better? I don't know. Nope, nope, nope. We're worse. We're worse now. Exception calling any. The term equals? Exception calling any with two arguments. The term equals is not recognized as a name of a... Why equals? I have double equals. What did I do wrong here? Okay, so func student bool param huh. Okay, I might have it in the wrong place. So quantifier operations. So system collections generic. Link any PowerShell. Oh no. Okay, so they used any here. Uh-oh. I was rather hoping to just use any in PowerShell as well. Intrinsic where test. Wait a minute. Hold on. So this one says use the original link any. So this one just has link enumerable. Wait a minute. Did I misunderstand this? Does this take a predicate? Yeah, they passed a predicate right here. The complaint was, okay, hold on. So they did it without saying system. So it said exception calling any with two arguments. The term equals is not recognized as a name of a commandlet, etc. Yeah, this is what I get for just trying to guess randomly at what might work. So I put this student. So they are using a predicate here, and here they use a dash include. Okay, yeah, let's do this. So let's say where, because we already knew that worked over there. I'm just going to put system back in here again since I had that before. So we'll say, we'll filter where, and then we'll put a length. Oh, I don't know what I just did. What the heck? What am I pressing? It keeps happening. Just start again. Okay, so dot. Wait, what does dot period do in? I definitely should have known that. I was trying to think of that too. But anyway, so length not equals 0. Can we do that? What's it gonna say? So on 52, I screwed it up. Wait a minute. So if, did I screw it up on 52? I mean, it says I did. Oh, not equals. Just messed up again. Oh, 3 passed now. 4 were passing at one point. Okay, so oh, so expected true but got false in a particular case. So if the so we were trying to add the student, but we apparently didn't. So length, so if the length not equals 0, then we were supposed to return false without trying to add anything, right? Okay, hold on. Let me clear again, and hopefully I won't take too much longer on this one. Okay, so add a student, expected true but got false. So we went add student to Amy, should be true. So, okay, yeah, so none of them worked. So I guess I don't know if this where is working. So intrinsic where, this looks nice. Let's try it a little bit more like that if possible. So instead of whatever I was doing, let's say if, and I'll say this students, and I will say where, and I will pass this. So this syntax, so they put a dollar underscore just for whatever was passed in there, I guess. Seems like it would be something very worth looking up, but anyway. So where can we put dot name here? I'm leaning towards not, but maybe. And we'll put equals. Oh, we have to put dash EQ. You know, honestly, maybe that was the problem all along. So what's the first here for? Oh, ensures the method returns once the first match has been found. That's lovely. Somebody knows what they're doing when it comes to PowerShell. Kudos. That's awesome. All right, so then we'll say count. So I've basically just copied that to the extent that I feel that I must include a credit. PowerShell comment. Credit to right here. That seems like a very comprehensive answer. Okay, so we'll get rid of this. Okay, so is it any better though? Yes, 6. That's the best so far. All right, so what's this next one? So expected true but got false on Amy. Okay, so that's no good. Okay, so let's look at the tests. Yeah. So Amy, get roster should be null or empty. So we just tried adding this. Okay, so it's no good. So what did I mess up here? So credit, okay, so if this student, so I don't know if I would expect that to work. Let me try it more like the param thing. I don't know if that's any better because I don't know if that ever, I don't think that ever did work. But I'll just put param $s, s name. I don't think that's any different. Well, I don't know. I don't. Nope, it made it worse. I guess I will revert then. So then what? So why can't we add Amy? So we're supposed to say, oh hey, if we find something where the name equals $name, then we're supposed to return false. Ha! Okay, so how do we even print? I think it's like, is it print line? I'll just look it up. Print line. How to output something. Okay. Okay, so let's try. Write host. And then we just put whatever we're writing. $name. Okay, okay. So Amy came in. Add a student. Student is added to the roster. Okay. Yeah, so there's nothing there, and I mean, yeah. So we're not succeeding in adding anything. Unless this is. What's with student? Oh, yeah, interesting. So, okay. So it looks like something is added. So James is added. Oh my gosh. Okay. So when it's, I'm not exactly. So some were getting added and some weren't, I guess. What do they call map and link select? PowerShell where? Wow. Okay, very nice. I'm gonna credit this one as well. Okay, so we're gonna go type to percent, and then we put a whatever. Is it a lambda? Oh, interesting. Let's see what comes out. Amy, nothing. So it's student, 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 student. So this is probably not right. Or can we pipe to write host like this? Is that, am I crazy? Yeah, seems crazy. But in any case, like it's not working. Like, okay, what is not working here? PowerShell array string join. Hmm. Hmm. Let's see what we're doing here. Yeah, so we did that. About arrays. No. We'll look at this one again. Have an array. Yeah, so this is an array. Okay, so they made this an array. Okay. Let's see. So this is not students. Okay, we'll try this again. Percent name join string. No, let's do join. What's it say? Expressions only allowed as the first element of a pipeline. Yeah, so that's no good. Can we do like a temp variable? Declare var in PowerShell? Oh my goodness, I don't know anything about variables. Yeah, okay, so we'll say temp equals. Okay, so we won't do join. So we'll return temp join. All right, let's see. There we go. All right. That's fair. Okay. Let's see what we've got. All right, so it doesn't really look right at all, right? So we've got Amy, Amy. Okay, so now let's try printing. So write host. Write host. This names. Maybe. I don't know. Okay, yeah, you know what? That does look better. Okay, so fine. We were able to add Amy? No, we returned a false. Amy, Blair. Okay, so Blair, James Blair, Paul Blair, James Blair. So I guess, so does this mean Blair was added? Okay, so Amy, Amy, Amy. Blair, James, Blair. Oh. Okay, I don't want that. I want this here, I believe. Okay, so yeah, it does say false. Oh my gosh. It says false, but it didn't go in there. It was supposed to be else plus equals, and then it was supposed to be return true. Is it true like this? No. Shoot. PowerShell bool. Come on, it's just true and false. Right? Oh my gosh. I'm a little surprised that it didn't warn me, but okay. I thought it would have said something, to be very honest. Okay. Okay, well, I guess it doesn't have to say anything. So 12 passed now. All right, let me get rid of those printouts because they're weird. I was very confused. I I guess I just imagined that it would have warned me if I was using some random word that didn't mean anything. All right, so what's the failure now? Students are sorted. Okay, I'll do sorted last. Grade is empty if no students in that grade. Okay. Wait a minute, wait a minute. Does it say where this was? Oh, I know where this was. So this part, this we cannot expect to work. But we should be able to do what we saw with the credit to Stack Overflow. So we're going to say this student where underscore, we'll put grade equals grade. I think that's it. Okay, so we had 12. Are we going to have more now? I don't know. We'll see. 16. Yes, that is more. Okay. Is all that's left the sorting? We have 1 sorting, 2 sorting, 3 sorting, 4 sorting. Okay, all that's left is the sorting. And then we'll move on. This one honestly bothers me just as much as the Lua one did. But that's okay. We'll get through it. So when we do get roster, these should be sorted. So we did where. You don't suppose it would be sort. Okay, let's see. PowerShell sort array. Let's see what it says. You can use sort object. Sort object. That sounds like a winner. So we're going to say we want... So we'll do a property. And when we pass a property, is it just the property name? I think it is. So they did WS. Okay, let's just try it then. Okay, so it'll be sort object. Okay. The property. Well, wait a minute. So they're doing like a pipe into it, which is actually, I think, probably fine. I'm not sure. So we'll do, let's see. It's going to be this student's pipe property, and the property name will just be name, or do we do grade first? And we should make sure we say that it is, oh, so descending, but we want ascending, so we're good there. I think that's enough to make one of them pass. I'm not sure. Let's see. Oh, yep, we're up to 17. Okay, so it's sorted by name in the roster. So we said we expected Alex, Peter, Zoe, and we got Peter, Zoe, Alex. Okay. So we're going to do... We're going to first sort by name, right? Oops. Sort object on property name. Okay, and then this time it needs to be stable, so we keep the previous work, I guess. Let's see, will that make 18 pass? 19, okay, last one. So in this case, it's get roster 5, sorted by name in a grade. Okay. So here we will do sort object property property Is that the last one? I'm going to be happy to move on, baby. Nope, that didn't do it. It was supposed to be Bradley Franklin, but got Franklin Bradley. Oh, darn. Oh, it's not in names. What the heck? It was here. Okay, well, that's embarrassing. Oh, well. All right, how about now? I put it in completely the wrong method. All right, let's submit and move on. All right, are we accepted here? Let's find out. Passed. Okay. All right, let's close all these PowerShell thingies. So I believe I have time enough to finish at least one more tonight. If it's not too bad, we'll see. So, we did the grade schools. Okay, so this one is 2-bucket, and we're, oh, back to Elm. Okay, I think I had a pretty good time with Elm. All right, let's give it a shot. I don't know if I can finish one in Elm. It might take me a while. We'll see what it is. So this one is called 2-bucket. All right, let's see what it's about. That was not what I meant. Okay, so given 2 buckets of different size and which bucket to fill first, determine how many actions are required to measure an exact number of liters by strategically transferring fluid between the buckets. So there are some rules that your solution must follow. Only do one action at a time. There are only 3 possible actions. Pouring one bucket into the other bucket until either the first bucket is empty or the second bucket is full. Emptying a bucket and doing nothing to the other. Filling a bucket and doing nothing to the other. Okay, sure. After an action, you may not arrive at a state where the initial starting bucket is empty and the other bucket is full. Okay, so we're gonna. What is this about? Um. I'm not sure why it says that yet. Let's see. So we'll have 2 different sizes. We have a desired number of liters, and which to fill first, either 1 or 2. Okay, so the total number of actions. Which bucket should end up with the desired number of liters? So one nice thing about this one is I do not think I have ever seen this problem before, so that's cool. So let's look at the example. I am probably going to have to work this out on paper. Okay, so I'm going to look at this example and try to work this out on paper. So the sizes are 7 and 11. And wait, why would it be? So why are we skipping to this given step? Okay, that's fine. Why these examples are not what I expected. So the desired number of liters. Okay, well, let's just say that we have 7 and 11, and the desired number, like, yeah, what is the desired number? All right, so if the desired number is 7, then we need to take only one action. We just fill it, we fill the first bucket, and we're good. If the desired number is 8, Then we fill the first bucket, but we only have 7, so we need to take another action. So what are we going to do in that case? We are going to well, let's see. So after an act, this seems pretty restrictive. So if the desired number is 8, we can fill the other one to get 11, and now we have a total of 18. All right. So that would be a second action. That would be action 2. And then so now we're not allowed to dump out bucket 1 at this point. So what we could, I'm actually confused about how we solve this one. All right, let me spend some time thinking about it. So if instead of filling the second bucket, let's say that we poured the first into the second. So then we still have 7, but the first has 0 in it, and the second has 7 in it. So that is allowed because it's not full. So it's not full, so that is allowed. So then if we were to fill the first bucket after that, then we'd have 14. Doesn't really seem to help. So like, can I get to a desired number of 8? Ah, you know what? Actually, let's look at some of the test cases. Okay, so measure, wait. 3511. Okay, so this is the starting bucket. I have 3 and I have 5, and we want to get to 1. Okay, so we start with 3 liters. So now if we dump those into bucket 2, then we still have 3. If we fill bucket 2, then we have 8. If we were to pour into bucket 2 and then fill bucket 1 again, then we would have 6. So if we have 6, that might make sense because if we have 3 in each, then yes, then we can dump bucket 1 into bucket 2. It'll overflow and we'll have, no, we're not allowed to. We're not allowed to empty bucket 1 into bucket 2. Shoot. And did they say anything about overflowing? So if we pour 1 into the other, oh wait, oh no. Okay, so we don't overflow. We don't overflow. So we just pour 2 out of 3 from the first into the second. So then we have 1 in the first, and we have 5 in the second, and then we just dump out the second, and then we have 1. Okay. For some reason, I wasn't thinking about being able to do this. Okay. So let me work through that example again. We have 3 in one bucket, and we have 0 in the other bucket, but the capacity is the capacities are 3 and 5, and the target is 1. So with our first action, we can pour bucket 1 into bucket 2. So then I have 0 in the first and 3 in the second. That's 1 action. All right. Then I can fill the first again, so now I have 3 and 3. And that's a second action. So now I can pour 2 out of 3 from the first into the second. So now I have 1 and 5, and that's a third action. And now I can empty the second. I now have 1 and 0. That's 4 actions. So how do I know that I've used the least possible number of actions? Is this going to be a backtracking thing? I'm not sure. Let's look at another test. So in the second one, it's 3 and 5 again, but we start with we start with 5 filled. Okay, so I've got capacity of 3 and 5, and the target is 1. So we start off with 5 in the second and 0 in the first. So now we want to do what? We can technically pour 3 out of the 5 into the first. So now we've got 3 in the first and 2 in the second. That's 1 action. Is that what we want to do? So now we're not allowed to dump out the 2, because then we would... Where was that rule? So yeah, so then the starting would be empty and the other would be full. So we're not allowed to dump out the 2. So what do we do instead? I actually really don't know. Oh, we could dump out the first, so now we have 0 and 2. That's a second action. Now we can dump the 2 into the first, so now we have 2 in the first and 0 in the second. That's 3 actions, and that's okay because we haven't filled it. It only has 2 out of a capacity of 3 at that point. And so then, when we have 2 in one and 0 in the other, what can we do from there? I thought it seemed like a good idea, but... So at this point, our only option really would be to fill the original. So now we have 5 in there and 2 in the other. That would be a fourth action. So now we can dump out, or no, we can dump 1 into the first, so we've got 3 and 4, and now dump out the first, so we've got 0 and 4, that's a fifth and sixth action. Then we can pour 3 into the first, so we've got 3 and 1, that's a seventh, and now we can pour out, and then we've got the 1, so that would be 8 actions. Is 8 actions what it said in the test, or was it fewer than that? Oh, it was 8. It was 8 moves. Interesting. So it's definitely systematic. For some reason, if I've ever seen this before, it would have been many years ago. Like, probably when I was, like, in grade school, in elementary school, probably. I don't think so. I think I've never seen this before, but it does seem like we want to take a systematic approach. Let me work through this next one on paper. So we have 7, 11, and 2. So we start off, so the capacities are 7 and 11, the target is 2. We start with 7 and 0. All right, so then what do we do now? We are going to basically, do we want to pour the 7 into the other? Okay, so the target is 2. So I don't think we want to fill the other. I think we want to pour the 7 into the other. So we've got 0 and 7. That would be our first action. And then we could fill the 7 again. So now we have 7 and 7. That's 2 actions. And now we can pour 4. So we have 11. That one's full. And now we have 3 over here. So that's 3 actions. Does that bring us closer? I'm not sure yet, but let's see. So now do we need to dump out the 11? I think so. So then we'd have 3 and 0. That's 4 actions. And then we can dump the 3 in. So we have 3 and 0. That's 5. So now if we fill this again, we have 7 and 3. That's a 6th action. Then we can pour, so we have 10 and 0. That's a 7th. Then we fill again, 7 and 10. That would be an 8th. Then we pour, so we have 6 and 11. That's a 9th action. And then I guess we have to dump out the other one. So we have 6 and 0. That's 10. Then we can pour the 6. So we have 0 and 6. That's 11. Yeah, so the thing is there's just not very many actions available at each step, right? But as far as I know, like, I'm probably still going to mess up somewhere and get a wrong action. So I don't know if backtracking is going to be necessary. So 7 and 6. I don't think so. It seems systematic. I just have to make sure I get the right system. Hopefully, because that'll be easier than backtracking. Although I should not fear backtracking. I should just get used to it. Okay, so then we pour 5. So we've got 11 and 2. That's a 13th. And then we pour out at the 11, and now we're 2, so that's 14. Is that what they had? Yes. Okay, so it does seem systematic. I'm just gonna keep working through these until I feel like I have it down, because I don't feel like I have it down yet. Next page. So this time it's 7, 11, and 2, but we start with number 2. Okay, so 7 and 11 are the capacities. 2 is the target. We start with 0 and 11. Okay, so we'll pour 7 into the other. So now we've got 7 and 4. That's a first action. All right, so now we'll pour out the 7. We've got 0 and 4. That's a second. So now we'll pour the 4. So we've got 4 and 0. That's 3 actions. So now we'll fill the 11 again. So that's 11 and 4. That's 4 actions. Then we'll pour 3, so that's 7 and 8. That's 5 actions. We'll dump out the 7, so that's 0 and 8. That's 6 actions. Then we'll pour 7, so that's 7 and 1. That's a 7th action. We'll dump the 7, so 0 and 1. That's an 8th action. We'll dump the 1, or we'll pour the 1 into the other bucket, so that's 1 and 0. That's 9 actions. We'll fill the 11, so that's 11 and 1. 10 actions. We'll pour the 6, so that's 7 and 5. That's 11 actions. Then we will dump the 7, so that's 0 and 5, 12 actions. We'll dump the 5, so that's 5 and 0, 13 actions. We'll fill the 11, so that's 11 and 5, 14 actions. We'll pour the 2, so that's 9 and 7, 15 actions. We'll dump the 7, so that's 0 and 9, 16 actions. We'll pour the 7, so that's 7 and 2, 17 actions. We'll dump the 7, and then we have 2 left, 18 actions. And 18 is what they've got. Okay, well, you know, I'm glad I worked it out on paper, because otherwise I wouldn't have known that it seems so straightforward. I wonder if I've been misled. I'm going to keep working through them. All right, so this time we have 1 and 3. The target number is 3. We start with the third bucket, so we need 0 actions. Oh, it has 1. So wait a minute. Okay, so this is maybe a little bit of an edge case. So in this case, we started out with what I thought was... Wait a minute. Okay, let me go back and look at the glow again. Let's see if I understand this better. So, given 2 buckets of different size and which bucket to fill first, determine how many actions are required to measure an exact number of liters by strategically transferring fluid between the buckets. There are some rules that your solution must follow. You can only do 1 action at a time. There are only 3 possible actions. Pouring 1 bucket into the other bucket until either the first bucket is empty or the second bucket is full. Okay, nice. Emptying a bucket and doing nothing to the other. Filling a bucket and doing nothing to the other. After an action, you may not arrive at a state where the initial starting bucket is empty and the other bucket is full. Your program will take as input the size of bucket 1, the size of bucket 2, the desired number of liters to reach, which bucket to fill first, either bucket 1 or bucket 2. Your program should determine the total number of actions. It should take. Okay, so I think I know what I've done wrong. Let me finish reading though. The total number of actions it should take to reach the desired number of liters, including the first fill of the starting bucket. So that is one mistake. I was not including the first fill up until now. And then which bucket should end up with the desired number of liters, either bucket 1 or bucket 2. So I had been doing 1 extra step at the end to get the total number to the target number, and that was not necessary. And then how many liters are left in the other bucket? So anytime a change is made counts as 1 action. Okay, and so the examples threw me off, but let's see. Bucket 1 can hold up to 7, bucket 2 can hold up to 11. Let's say at a given step, bucket 1 is holding 7 and bucket 2 is holding 8. If you empty 1 and make no change to 2, then you have 0 and 8. That counts as 1 action. Instead, if you had poured from 1 into 2 until 2 was full, resulting in 4 in bucket 1 and 11 in bucket 2, that would also only count as 1 action. Okay. Bucket 1 can hold 3, bucket 2 can hold 5. You are told you must start with bucket 1, so your first action is to fill bucket 1. You choose to empty bucket 1 for your second action. For your third action, you may not fill bucket 2 because this violates the third rule. You may not. Okay, fair enough. Okay, so then let me just see. So in the tests, in this first one, let's see, what's that? Let me look at the test again. Oh, not that. Okay, so the first was 351. So this was 1 move to fill 3. So I'm going to write it on the other side. 1, 2, 3, 4. And then the other bucket has 5 in it. Okay, yep. The next example, I'm going to write the moves on the other side. So 1, 2, and I just keep going until one of the buckets has 2 in it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, and then the other has 11. And is that what we... Wait a minute. Oh, I'm in the wrong place. So this one has 11. Did I skip over one? Oh yeah, I did. I wrote it on the same page because it was short. So we're looking for 1. So 1, 2, 3, 4, 5, 6, 7, 8 moves, and the other has 3 in it. So that is what we see. Okay, cool. Okay. Next example, we're going for 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 moves, and the other bucket has 7 in it. No! Is this where I was supposed to be? 18 moves, and it has 7 in it. That was the 4th? Okay, yeah, that's where I'm supposed to be. Okay, so then the 5th example, Did I work through it yet? Okay, so this is the one that threw me off. So we just we fill bucket 2, and we only needed one move, and it's 0 and 3. Great. Okay, next example is going to be 2, 3. Okay, so 2, 3. The target is 3. We have to start with... Wait. We start with 1. So first move, we put 2, and we have 0 in the other. Second move, we fill the other, and so it only took 2 moves. Is this the one I was looking at? And it was 2 and 3. Okay. Uh-oh. 6, 15, and 5. Okay. So this is going to get a little more complicated, clearly. Okay, fresh page. So one bucket is 6, the other is 15, the target is 5. We start with 6. So our first move, we have 6 and 0. Our second move, so we're looking for 5. So I'm going to dump the 6 into the other. So I have 0 and 6. Third move, I'm going to fill the 6 again, I think. So I have 6 and 6. Fourth move, I'm going to pour the 6, so I have 12 and 0. Or 0 and 12, rather. Fifth move, I'm going to fill again. So now I have 6 and 12. Sixth move, I'm going to pour, so now I have 3 and 15. Seventh move, I'm going to dump out the 15, so I have 3 and 0. All right, eighth move, I'm going to pour the 3, so I have 0 and 3. Ninth move, I'm going to fill the 6, so I have 6 and 3. 10th move, I'm going to pour the 6, so I have 0 and 9. 11th move, I'm going to fill the 6, so I have 6 and 9. 12th move, I'm going to pour the 6, so I have... Oh, no, I'm not allowed to, because then I would have 0 and 15. So my only option would be to either pour out the first, which would bring me back, or pour out the second, which would bring me back all the way to move 2. So I think what we're looking for is we're discovering that we've found a loop where we cannot progress. I don't think backtracking is required, but I do think that we will need to track like previous game states, basically. The reason I don't think backtracking per se is required would be because, like, for the most part, you just pick the same moves every time. Now, this one was an exception. Which one was? This one. This one was an exception because we had to fill this one first, but then instead of pouring it into the other, we just filled the other because it had the right capacity. So that's like a special case that you have to treat separately, I believe. Okay, so if it's too big, then we can just rule that out right off the bat. And then, oh, okay, so then same buckets, but this time the goal was 9. So let me find 9 on here. So we reached 9 on move 10. It was 0 and 9. So 10 moves. Okay. Let's see. I only have about 10 to 15 minutes left that I want to use tonight. Which languages are there for 2 buckets? So we could do Elm, we could do VLang, or we could do Crystal. So I'm going to try it in Elm and see how it goes. I do not know what VLang is. Let me see what what is VLang? V is still in beta development. 679 students. Huh. It seems like, I don't know, what do I want to say about this? It seems like it's like relatively, I don't know, obscure. That sounds a little negative. Do we have any, do we have any idea of like how well known this might be? Okay, so it is on Wikipedia, so that's good. It is created in 2019. Do you think it's the most page viewed of the three? I'm guessing probably yes. Let's see. Yeah, by a good amount. If we were to compare it to programming languages, there's a good amount here. Let's see the page view counts. So let's see where it ranks. Here, between Simula and Agda. Okay, well, by these page view counts, I guess I wouldn't call that very obscure. It's above Vala and Gleam, so people are clicking it on Wikipedia. So I guess my initial impression was wrong. I guess it's not really that obscure. Cool. Do we know like what it's typically used for? You know what? Let's just dive right into it. Let's try it in V. Let's find out something about it. Install V's tooling. Let's take a look. It is highly recommended that you install from source and then follow the instructions. So if that's highly recommended, that is what I will do. However, actually, maybe I won't, because install from source usually, like, it just runs for a long time, you know? So if I could use it, if I can do it through brew, I'd rather do it, excuse me, God. I'd rather do it through brew. Because it's much faster usually. Z for Vim. Okay, well, this is the wrong thing. I'm hesitant. We could probably just do it with Docker. Would that be better? It says this is the preferred method. You know what? Let's give it a shot. Here we go. We'll git clone this guy. Okay, we're gonna try it. We're gonna clone the V project from VLang. Okay, we're gonna go into V. We're gonna make. We'll see how long it takes. Maybe it's fast. I always get nervous because usually like build from source usually takes a long time. And I'm all about the convenience, baby. That's why I use brew. Brew is usually extremely convenient. I don't know. I don't have a good idea yet. Oh, wow. Bravo. Bravo. That was so fast. Oh man, I was all nervous. That is awesome. Absolutely fantastic. Okay, let's try the hello world. Where am I trying to go? VLang. Hello. Yeah, here we go. Okay, let's try the test. Okay, so not found in path. Where did it say it put it? So it said it was successfully built. So it is there. So CDB. So is this where it was built to? Okay, so the V is right there. So let's add that to our path. I'm going to move it in. Okay, so let's make bin and CPV. Is that going to be okay? I'm guessing probably. And so then in our, so this is home Josh exorcism V bin. Okay, so let's look in the vim RC or in the ZSH RC. Nope, not that. All right, so I'm gonna export path equals home exorcism v bin. Okay, now let's try VLang. Let's see. I don't know. I don't know. Yeah, it was wrong. Let's do this again. So I guess we don't want vim bin. Let's just get rid of it. Let's try again. Oh, much better. Okay, let's submit. I'm not gonna finish this one. But I think it was a pretty decent run today. I feel good about stuff. I don't know. I feel good about stuff. I don't know. I think I actually finished a decent number. I didn't count how many I finished exactly. Yeah, it's just about time that I'm gonna log off. So let me just take a look at how many I finished today, actually. I think it was it 3? It might have been 4. So today, okay, I finished this yesterday and this yesterday. Today, I did this one and these 3, so I finished 4. So, I mean, that's not great. I really enjoyed this Clojure Bake account. Like, very, very cool. Something about the way this Lua code was got me grumpy. Like, this is one where it'll be good to look at community solutions to see how to do it, like, properly. Because I think this solution is quite ugly. But for the other ones, like the Gleam solution was nice. I enjoyed this one a lot. I think Gleam seems like a very nice language. Yeah, I enjoyed this one a lot. Again, if I look at the community solutions, I'm sure there are very good solutions. Then PowerShell, I didn't really have a great... you know, I think I learned some things that were kind of cool. I enjoyed this more than I enjoyed the Lua. I think honestly, if I were to go back and do the Lua with an approach more like this, I think I would like it a lot better. So it might be worth redoing it. So then 2 bucket is, I'm gonna tackle 2 bucket. I'm gonna try to finish it in all 3 languages tomorrow. I mean, since I spent all that time working it out on paper or whatever. So it's gonna be Elm, VLang, and Crystal. So I still don't really have a good idea of VLang. Let me just, so I opened it up in Wikipedia, but I didn't look at any of the information. So inspired by Go, other influences including Oberon, Swift, and Rust. I haven't heard much about this one. Did people used to talk about this more? It's a Pascal related project somehow, or is it? It's somehow related to Pascal. Okay. And then ease of use, readability, maintainability, sounds smart, Weasel. Let's see. So you have to use the walrus to define a new variable, kind of like in Go. I guess that's cool. Okay, so the method definition is very similar to Go. Well, it looks like a winner. So does the compiler use LLVM? Not that it really matters, I'm just a little curious before I move on. I'm not even sure where I would look to see if it uses LLVM. Add a WebAssembly compiler backend? Oh, huh, interesting. I would most likely look in like the commit messages. It looks like they're using pretty verbose commit messages, which I do like. Plenty of contributors too. Very nice. Very nice. Cool. Oh, interesting. Okay, so they are using MSVC here, so they must, I guess they must be using several compiler backends or whatever. Okay, let's search. Clang. Huh. So I definitely am going to have to learn a lot about some of these topics. In any case, I think that's it for tonight. I will come back. I will plan to come back tomorrow, same time. I work again tomorrow, and I'll plan to come back again from 5 to 9 tomorrow. And I think that'll be awesome. And I am looking forward to doing this 2 bucket. I mean, it does seem simple. Simple-ish. So I'll see how it goes. Right? Like it's really just like some repeated arithmetic, not unlike the Collat's conjecture. It's actually rather similar, I think. So yeah, it does seem rather similar to the Collat's conjecture. Are there any others here that seem like similar to that? I think Pascal's triangle is basically similar-ish. Scrabble score, no, Scrabble score is not really that similar. Um, let's see. Is Civ similar? Not really that similar. Vaguely similar. Okay. Well, yeah. I think it's interesting because I'm pretty sure I've never seen this problem